MS Ramaiah University of Applied Sciences.
Hello students, let us discuss the design and implementation of multiplexer and demultiplexer circuits. Aim of the experiment is to design and verify the functionality of multiplexer and demultiplexer circuits. Multiplexers are mainly used to increase the amount of data that can be sent over the network within a certain amount of time and bandwidth. Multiplexers can also be used as components of programmable logic devices. By specifying the logic arrangement in the input signals, a custom logic circuit can be created. The selector inputs then act as the logic inputs. This is especially useful in situations when cost is a factor and for modularity. Analog multiplexers, demultiplexers are used in several applications such as data acquisition systems, automatic test equipment systems, audio signal routing, battery power systems, medical instrumentation, and single supply systems. 4:1 multiplexer logic diagram and the truth table are shown here. 4:1 multiplexer logic diagram and truth table with an enable input are shown here. The demultiplexer logic diagram and corresponding truth table are shown here. The apparatus required for this experiment are training kit, connecting probes, IC 7408, 7404, 7411 and 7432. Procedure for verification of multiplexer and demultiplexer. Collect the components necessary to accomplish this experiment. Plug the IC chip into the breadboard. Connect the supply voltage and ground lines to the chips. Pin 7 is ground and pin 14 is +5 volts. Make connections as shown in the respective circuit diagram. Connect the inputs of the gate to the input switches of the LED. Connect the output of the gate to the output LEDs. Once all connections have been done, turn on the power switch of the breadboard. Operate the switches and fill in the truth table. Write 1 if LED is on and 0 if LED is off. Apply the various combinations of input according to the truth table and observe the condition of output LEDs. Conclusion: the multiplexers and demultiplexer circuits have been designed and verified for their functionalities.
Hi students, name of the experiment is Design and Implementation of Multiplexer and Demultiplexer Circuits. Aim of the experiment is to design, implement and verify the functions of multiplexers and demultiplexer circuits. Apparatus required for this experiment are digital IC trainer kit on which we are going to perform the experiment. So here you can see on the top of the digital IC trainer kit, you can see the knobs here. So 10 are in the red color, 10 are in the black color. So these are the output knobs. So here the bottom you can see the 10 black color knobs. Here we are going to connect the inputs, and inputs can be varied by varying the toggle switches which are present here. So if you keep the toggle switch to the top position, that means the input is high, and if you keep it to the low position, that means the input is low. So output can be verified by looking into the LEDs. If the LEDs are on, that means that particular output is high. If LED is off, that means the particular output is off. And here also you can see there are 4 IC bases, so where you can place the ICs. Each IC base has a IC slot, so where you can place a IC. So here each IC base consists of 16 slots. So and also there are 16 pins at the left side of the IC base as well as the right side of the IC base. Total 16 pins are there. So these are internally connected to the each slot. And also each IC base consists of VCC and ground. So VCC and ground are used to give the power supply to the IC connected here. And at the bottom you can see there is a clock signals of various frequency, 1 Hz, 10 Hz, 100 Hz, 1 kHz and 10 kilohertz. And at the right side you can see there are two yellow color knobs which are used to check the conductivity of the patch cords. So if you can connect a patch cord here and you can see if the LED bulb is on and if the beep noise is coming, that means the patch cord is working properly, otherwise the patch cord has some problem. 4 ICs. So these are the 4 ICs which we are using in this experiment. So one is NOT gate, then these two are 3 input AND gates, and this is OR gate and patch cords. These are the patch cords we are using to connect the logic diagram. So before using any patch cord to connect the given logic diagram, we have to check the continuity test for each patch cord. Take the patch cord, turn on the power supply to the digital IC trainer kit. It is turned on now. Now place the patch cord between the continuity tester knobs, and you can see there is a LED on and there is a beep noise. So this means the patch cord is working fine, and similarly we have to check continuity test for all the patch cords which we are using for the experiment. Now let us place the ICs into the IC base. First I am taking NOT gate, that is 7404. So while making the IC into the IC base, make sure there is a notch on the every IC, so that notch should always be in the upward direction. So I am placing into the IC base 1. So after placing into the IC base, close the lever. Similarly I am taking the second IC, that is 7411. This represents 3 input AND gate. I am placing into the second IC base. After placing it, just close the lever. Similarly third IC into the third IC base, close the lever. Similarly the last one is OR gate. I am placing it here, and after placing it here, just close the lever. Now let us implement 4:1 multiplexer according to the logic diagram using logic gates. Now let us start connecting the circuit according to the logic diagram. So now before doing that, I am going to connect VCC and ground to all the IC bases. It gives power supply to the IC connected to the IC base. So, and also we should see pin number and last 2 slots of every IC base is left free, because the IC we are using consists of only 14 pins. So therefore the last 2 slots are left free. So therefore pin number 8 and pin number 9 we are not considering for the connections. So after 7, pin number 10 we have to assume as a pin number 8 and 9, and it will go on till pin number 14. Now similarly I am connecting VCC for pin number 14 of the second IC base, and ground pin number 7 as a ground for the third IC base. Pin number 14 is VCC, pin number 7 is ground, pin number 14 is VCC, pin number 7 is ground. The 4 ICs are connected here. So the first IC represents NOT gate, second and third IC are 3 input AND gates, and the fourth IC is the OR gate. Now let us start connecting from the first IC, that is NOT gate. So pin number 1 of the NOT gate is connected as one of the input, that is the select input, that is S1. 2 of the NOT gate is connected to pin number 1 of the 3 input AND gate. Similarly, same pin number 2 of the NOT gate is also connected to pin number 3 of the AND gate. Then pin number 3 of the NOT gate is connected as one more input, that is select line S0. This one is S1, this one is S0. These are 2 select lines to choose the proper input. And pin number 4 of the NOT gate is connected to pin number 2 of the AND gate. Now pin number 13 of the AND gate is connected as one of the input, that is I0. Now pin number 4 of AND gate is connected to the S0 input, select input, that is here. Pin number 5 of the AND gate is connected as another input I1. Pin number 9 of AND gate is connected as a select line 1. I am connecting here in the input select line. Pin number 10 is connected to S0 again, select line. Pin number 11 is connected to third input, that is I3. Next, pin number 1 of the another 3 input AND gate is connected to the input select, that is S1, select input. Pin number 2 is connected to the select input S0. Pin number 13 is connected as one more input, that is I3. So that there are 3 inputs, I1, I2, I3 and I4, and 2 select lines S1 and S0. Based on the selection of S1 and S0, these inputs will be chosen. Now pin number 12 is connected to pin number 1 of the OR gate. Then pin number 2 of the OR gate is connected to pin number 6 of AND gate, that is 3 input AND gate. Pin number 8 of the 3 input AND gate is connected to pin number 4 of the OR gate. Pin number 5 of the OR gate is connected to pin number 12 of the second 3 input AND gate. Now pin number 3 of the OR gate is connected to pin number 9 of the same OR gate. I see. Now pin number 6 of the OR gate is connected to pin number 10. Now pin number 8 is connected as output. So this completes the connections. Now let us check the output of the 4:1 multiplexer according to the truth table. So you can see there is a 1 output and there are 4 inputs. Based on the selection of the input selector lines, the output will be chosen. So now before doing that, we have to turn on the power supply to the digital IC trainer kit. So power supply is on. Now this represents the first input, second input, third input and fourth input. So now based on the selection of the selection lines, the inputs will get selected and the output will be high. So for example, if the input is 0 0, that means the first input has to be selected. So therefore I will make first input high. So therefore the output 1 is selected. If you turn on the output 2, 3, 4, output will not be selected. So therefore output 1 is selected. This is true according to the truth table. Now I will make the input to 0 1. So that means input 1 has to be selected, input 2 has to be selected now. So now if I make it high, so it is selected. So therefore this is correct. Then I will go for third combination 1 0. So third input has to be selected now. If I make the third input high, output will be selected. And if I make any other output high, it will not get selected. So now I will go for the third combination, that is 1 1. If I make both 1 1, that means the fourth input has to be selected. So if I make fourth input high, the output will be selected. So therefore this completes the experiment. We have completed an implementation of 4:1 multiplexer using basic gates. Now let us implement 4:1 multiplexer using NAND gates according to the given logic diagram. So these are the ICs which we are using to implement 4:1 multiplexer using NAND gates. So this is 7400 represents 2 input NAND gate, and I am going to place this into the IC base. Make sure while placing the notch should be always in the upward direction. So I am placing it into the IC base, first IC base. After placing it, just close the lever, and similarly there are 4 input NAND gates. This represents 7420. I am placing it into the IC bases. After installing it here, close the lever. Similarly, one more IC 7420, close the lever. The last one 7420, it's a 4 input NAND gate. Then close the lever. Let us start connecting the logic diagram as per the diagram. So I am connecting VCC and ground first for every IC base. So pin number 14 represents VCC, pin number 7 represents ground, and we have to be careful here that the last 2 slots are left free since the IC consists of only 14 pins. The IC base is for 16 pins, so therefore the last 2 slots are left free. So therefore pin number 8 and pin number 9 of IC base we are not considering. So after pin number 7 we are moving it to the pin number 10, and we have to consider pin number 10 as pin number 8, then 9, 10 and so on till 14. Similarly, VCC 14, 7 of IC is ground, pin number 14 is VCC, 7 of IC base is ground, again pin number 14 to VCC, pin number 7 to ground. Now the first IC base consists of 7400, 2 input NAND gate, and the next 3 IC bases has 7420 ICs. These are 4 inputs NAND gates. So now first, according to the logic diagram, I will short pin number 1 and 2 of the 2 input NAND gate, and I will also short pin number 4 and 5, and similarly pin number 9 and 10. So here there are 2 inputs, S1 and S0. These are the select lines along with enable. So enable is coming into picture here. So enable is also one of the input. So now I am taking these 3. One is S0, S1, S0 and enable. So now what we have to do is pin number S1, this S1 input, the select one is connected to pin number 1 of the 4 input NAND gate, that is here. Next, S0 is connected to pin number 10 of the second IC base, that is here. Pin number 3 of 2 input NAND gate is connected to pin number 1 of 4 input NAND gate. Pin number 2 of 4 input NAND gate is connected to pin number 6 of 2 input NAND gate. Pin number 4 is connected to pin number 8 of the 2 input NAND gate. Pin number 9 of 4 input NAND gate is connected to pin number 3 of the 2 input AND gate, that is here. Pin number 10 of the 4 input NAND gate is connected to S0 directly. So this is S0, I am connecting it here directly. Pin number 12 of 4 input NAND gate is connected to pin number 8 of the 2 input AND gate. So I am connecting here. Then pin number 2 of the 4 input NAND gate is connected to 6 of the 2 input NAND gate. pin number 4 of the 4 input NAND gate is connected to pin number 8 of the 2 input NAND gate. So pin number 5 is connected as I2 input. I am connecting I2 input. So now pin number 13 of second IC base, that is 4 input NAND gate, is connected as I1 input. I am connecting here. Pin number 5 of 4 input NAND gate is connected as input I0. Next, pin number 9 of 4 input NAND gate, that is in the third IC base, is connected to pin number S1 or input S1. I can connect here directly. Pin number 10 of 4 input NAND gate is connected to S0 again. I will connect here. Pin number 12 of 4 input NAND gate is connected to pin number 8 of 2 input NAND gate. Pin number 13 of 4 input NAND gate is connected as input, that is I3. So there are 4 inputs I have connected: I0, I1, I2 and I3. Based on the value of these two selectors, these 4 inputs will be chosen as the output with enable high. So now pin number 6 of the 4 input AND gate, that is here, is connected to pin number 1 of the 4th IC base as per the logic diagram. Pin number 8 of second IC base is connected to pin number 2 of 4th IC base. Pin number 6 of third IC base is connected to pin number 4 of 4th IC base. Pin number 8 of third IC base is connected to pin number 5 of 4th IC base, and pin number 6 of 4th IC base is connected as output. So I am taking pin number 6 of the 4th IC base and I am connecting as a output. So now enable, I have to connect to the pin number 9 and 10, which is shorted already. So pin number 9 and 10 are here, which is shorted already here. So therefore I have connected here. So now enable is connected. So this completes the circuit connections. So now let us verify the truth table of the 4:1 multiplexer using NAND gates. So I am going to turn on the power supply. So power supply is on now. So now there are 2 select lines, S1 and S0, and 1 enable line. So enable line always must be low, and there are 4 inputs. So 1, 2, 3, 4, and the selection of the 4 inputs is based on the selection of the select lines. So when the enable lines are 0, 0, the first input has to get select. So therefore when I make the first input high, it is going to select as a output. Now if you change any input, or if you make any output as high, output will not get select. So output will be selected only for the first input. Now similarly I will make the input selection line 0, 0 to 0, 1. So therefore that means the second input line has to get select. So the moment I make the second input line high, so output will get select. So similarly I will go for the third combination, that is 1, 0. So that time third input has to get select. If I make this third input high, the output will get select. And this is similarly for fourth input, that is 1, 1. So that means fourth input has to get select. If I increase the fourth input to logic high, if I make the fourth input as a logic high, the fourth output will get select, and the fourth output will not get any other outputs will not get select even if you make it high when the input selection like are 1, 1. So now this verifies the 4:1 multiplexer using NAND gates. So this completes the experiment.
At MSR UAS, we spark your imagination unlike any other.